In the previous lecture on trigonometry, we learned about some basic trigonometric ratios. Today, we'll learn trigonometric ratios of standard angles. Let's begin with 45 degree. We'll also learn how the values come, the proofs of the values. Consider triangle ABC, right angled at B, and let angle B equals to 45 degree. Then angle A plus angle B plus angle C equals to 180 degree. Angle sum property. Angle sum property is basically the sum of angles in a triangle is 180 degree. So angle A, let angle A equals to 45 degree. So angle A is 45 degree. Right angle at B, so angle B is 90 degree plus angle C equals to 180 degree, which implies this plus this is 135. 135 goes here. Angle C equals to 180 minus 135, that is 45 degree. So if angle A is 45, angle C is also coming as 45 degree. So let's make the triangle A, B, C. So this being 45, this being 90 degree, this is also coming out as 45 degree. Hence this triangle is an isosceles triangle. Let AB equals to BC equals to say A. Using Pythagoras theorem, AC square equals to AB square plus BC square, which is equals to A square plus A square, which is equals to 2A square, which implies AC equals to root under of 2A square, that is equals to root 2A. So the third side comes out to be root 2A. This is A, this is A. So sine 45 degree sum, let's consider this as the base angle, some people have, that is A by root 2A, which becomes 1 by root 2. Cos 45, curly brown hair. So this is the base, this is the hypotenuse. So A by root 2A will again become 1 by root 2. And tan A turns permanently black. So perpendicular by base is A by A, which becomes 1. So cosec 45 degree becomes root 2. Sec 45 degree becomes root 2. And cot 45 degree is 1. Next, let's see for angles 30 degree and 60 degree. So consider an equilateral triangle ABC with AB equals to BC equals to AC equals to A. Say we are calling AB, BC and AC this side as A. So This becomes our triangle. This side is also equal. Draw AD perpendicular to BC. So what we are doing is we are constructing AD perpendicular to BC. So in triangle ABD and triangle ACD, angle ADB equals to angle ADC, both 90 degree. Then AB equals to AC equals to A, and AD equals to AD. Common side. So right angle, hypotenuse and a side, a right angle, hypotenuse and a side. So therefore triangle ABD is congruent to triangle ACD by RHS axiom. So we know that in congruent triangles, corresponding sides are equal and corresponding angles are also equal. Therefore, BD equals to CD. Both the sides will be equal, and angle BAD equals to angle CAD, both of this by CPCT C. Now BC equals to A, and BC is basically BD plus CD. BD plus CD is BC equals to A, and BD is also equals to CD. So this implies CD plus CD equals to A, which implies 2CD equals to A, which implies CD equals to A by 2. CD or DC means the same. So this implies BC equals to CD equals to A by 2. So both these parts will be equal and equals to A by 2. Also, angle BAC equals to 60 degree, because each angle in an equilateral triangle is 60 degree. So this implies angle BAC. Angle BAC can be further broken down into angle BAD plus angle DAC. So angle BAD plus angle CAD equals to 60 degree. And we know that BAD and CAD are equal. So angle CAD plus angle CAD equals to 60 degree, which implies 2 angle CAD equals to 60 degree, which implies angle CAD equals to 30 degree equals to angle BAD. So we got this angle as 30 degree and this angle as 60 degree, because each angle in an equilateral triangle is 60. So let's take this triangle. In triangle ABD, using Pythagoras' theorem, AB square equals to AD square plus DB square, which implies A square equals to AD square plus A by 2 whole square, which implies A square minus A square by 4 equals to AD square. which implies AD square equals to 3A square by 4. So this implies AD equals to root under of 3A square by 4, that is equals to root 3 by 2A. So AD we got as root 3 by 2A. So let's take this triangle itself. We have 30 degree as well as we have 60 degree. So let's take 60 degree as our base angle. So sine 60 degree, some people have. We are only taking A, B, D. Okay, I'll redraw this for clarity. A, B, D. This we found out as 30 degree. This is 60 degree. This is 90. This is root 3A by 2. This is A. This is A by 2. So when we are taking sine 60, some people have. So root 3 by 2. A and A gets cancelled out. Cos 60 degree, curly brown hair. So A by 2 by A gets cancelled out, 1 by 2. Tan 60 degree turns permanently black. Root 3A by 2 by A by 2. So A by 2 gets cancelled out. We are left with root 3. So cosec 60. Cosec theta is the reciprocal of sine theta. So this becomes cosec 60 is 2 by root 3. Sec 60 degree is the reciprocal of cos 60 degree. So this becomes 2. And cot 60 degree is the reciprocal of tan 60 degree, which becomes 1 by root 3. Now for 30 degree, we'll take this as our base angle. When this is our base angle, this becomes the perpendicular and this becomes our base. So sine 30 degree. For 30 degree, this is our base, this is our perpendicular. So some people have. So A by 2 by A becomes 1 by 2. Cos 30 degree, curly brown hair. So root 3 by 2 by A becomes root 3 by 2. Tan 30 degree turns permanently black. A by 2 by root 3 A by 2. A by 2 cancels off. We are left with 1 by root 3. Cosec 30 degree, reciprocal of sine 30, 2. Sec 30 degree, reciprocal of cos 30 degree, that will become 2 by root 3. And cot 30 degree will be the reciprocal of tan 30 degree, which becomes root 3. Now we are done with 45 degree, we are done with 30, we are done with 60. Up next we have two more angles, that is 0 degree and 90 degree. First let's begin with 0 degree. So let's take a triangle over here. Say this triangle. Let this be theta, let this be 90 degree. So this theta, to become 0 degree, we need to keep reducing our perpendicular. See, if this perpendicular is getting reduced, what is happening is that if the perpendicular is getting reduced, this theta angle is also reducing. This angle has reduced. If we reduce this more further, this theta angle is more further reduced. As the perpendicular is keeping on decreasing, what is happening is theta is also keeping on decreasing. So it will reach a stage where this theta is so small that it has become 0 degree and the perpendicular has vanished. So as the perpendicular is slowly tending towards 0, theta is also tending towards 0. So over here, as perpendicular is tending towards 0, theta tends to 0 degree. And if you see, this hypotenuse is also decreasing lengthwise, and slowly this hypotenuse is quite equal to the base, and perpendicular approximately equals to 0. So if we say sine 0 degree, some people have perpendicular has become 0 by hypotenuse is say h, so this is equals to 0. Cos 0 degree, curly brown hair. So base and hypotenuse are equal, so base by base, which becomes 1. Cosec 0 degree, reciprocal of 0 is undefined. Sec 0 degree, reciprocal of 1 is 1. Tan 0 degree turns permanently black. So perpendicular is tending to 0 and base is basically base itself. So 0 by anything is 0. And cot 0 degree is the reciprocal of tan 0. Anything divided by 0 becomes undefined again. Up next we have 90 degree. Like in the case of 0 degree, what we were doing is we were reducing this perpendicular slowly so that theta became 90 degree. In this case, we need to increase this angle theta. To increase this angle theta, what we will do is we will reduce the base. So as this base keeps on decreasing, this angle keeps on increasing. As this base is decreasing, the angle is increasing. As this base decreases further, the angle is even larger. This reduces to such an extent that the base tends to 0 and the hypotenuse is almost equal to the perpendicular. So as base is tending to 0, theta is tending towards 90 degree, and over here as this base keeps on decreasing, the hypotenuse slowly gets equal to the perpendicular. Here hypotenuse is equal to the perpendicular. So over here again sine 90 degree, some people have hypotenuse equals to perpendicular, so this becomes perpendicular by perpendicular, which is equals to 1. Cos 90 degree, curly brown hair. Over here base is tending to 0, so 0 by anything is 0. Cosec 90 degree, reciprocal of sine 90, reciprocal of 1 is 1. And sec 90 degree, reciprocal of 0, which becomes undefined. Tan 90 degree turns permanently brown. So perpendicular remains perpendicular, base tends to 0, anything divided by 0 is undefined. And cot 90 degree, perpendicular by 0, if we take the reciprocal we get 0 by perpendicular, 0 by any positive value is 0. So these are the values for 0 degree, 30 degree, 60 degree, 45 degree and 90 degree. We'll construct a table with the same. Zero degree, 45 degree, 30 degree, 45 degree, 60 degree, 90 degree. There is a small trick as well to learn this. For sine, what you do is you write 0, 1, 2, 3, 4. You begin with 0, the whole numbers basically 0, 1, 2, 3, 4. Now what number did we end with? 4. So we will divide all the numbers by 4. Now we'll take positive square root in all of this. So what we see is 0 by anything is 0, root over 0 is 0, root over 1, 1, root over 4 is 2. 2 ones are 2, 2 twos are 4, root over 1 is 1, divided by root 2. Root under 3 by root 4 is 2. 4 and 4 cancels off to become 1, root 1 is 1. For cos, we'll just twist this over. So cos 0 is 1, root 3 by 2, 1 by root 2. This comes here, 1 by 2, and 0 goes to the end. For tan, we'll take the division of sin theta and cos theta by quotient formula. So 0 by 1 is 0, 1 by 2 by root 3 by 2 becomes 1 by root 3, 1 by root 2 by 1 by root 2 becomes 1, root 3 by 2 by 1 by 2 becomes root 3, and 1 by 0 becomes undefined. For cosec, we take reciprocal of sine. So reciprocal of 0 is undefined. Reciprocal half 2, root 2, 2 by root 3, 1. For sec, reciprocal of 1, 1, 2 by root 3, root 2, 2. Reciprocal of 0 is undefined. And for cot, we have reciprocal of tan, undefined, 0 is undefined, this is root 3, reciprocal of 1 is 1, reciprocal of root 3 is 1 by root 3, and reciprocal of infinity will become 0, because infinity is a very huge number. So when you divide by a very huge number, so it tends to 0, the value tends to 0. Please learn these values properly. In the next class, we'll deal with coefficients relating this, and also we'll be starting with a new topic.